In lesson 4, we looked at how we begin to set up our beginning trig ratios. So what we want to do is we want to be able to, based on this triangle, set up our sine, cosine, and tangent from each of our acute angles. So remember, for now, we never do trig from the right angle. We have to do trig from the one of the acute angles. And if we remember, we'll put it up here. We've got TOA. Remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So what I'm going to do is I'm going to put all of my sine of D, or all of my, I should say, trig functions from D. That's going to be my red. Now, the first thing I like to do is always put my O, my A, and my H in my picture. So if I go from D and I go out, that would make 15 my opposite side. That would make 8 my adjacent side. And obviously 17 has to be the hypotenuse because that's the one that's opposite the right angle. So for sine of D, our ratio is opposite over opposite over hypotenuse. So the opposite sine from angle D is 15. The hypotenuse is 17, so sine of D is equal to 15 over 17. For cosine of D, that's my adjacent over hypotenuse. That's going to be 8 over 17. And then tan, opposite over adjacent, gives me 15 over 8. Tan is the only fraction that is allowed to be greater than 1. Now, to do all of my trig functions from E, I'm going to put that in blue. And what you'll notice is the adjacent side that was for angle D now becomes not the hypotenuse, that becomes the opposite side. 15 turns into my adjacent side. And 17 still stays the hypotenuse because, again, that's still opposite the right angle, so that's not going to change. Sine of E, so opposite over hypotenuse gives me 8 over 17. Cosine gives me adjacent over hypotenuse, 15 over 17, and tan gives me opposite over adjacent, which is 8 over 15. And again, tan can be greater than 1, but it doesn't have to be. For number 2, looking at your answers from question 1, what do you notice about the sine of D and the cosine of E? And what about the cosine of D and the sine of E? So if we look at those fractions again, if you look at the sine of D, we had 15 over 17. You look at the cosine of E, we had 15 over 17. So we had sine of D equal to the cosine of E at 15 over 17. And then we had the cosine of D at 8 over 17, and we had the sine of E at 8 over 17. So we had those were equal at 8 over 17. Do you think that's going to happen in all right triangles? And the answer to that question is yes. When you switch acute angles, your sine and cosine fractions flip. And this is really going to lead us into, and maybe flip's not the right word because I don't want you to think of it as reciprocal. Your sine and cosine fractions switch. So that would be a better word to use. And this is really going to lead us more into lesson 5, but the sine of one angle is always equal to the cosine of the other. And that's going to be a rule and a strategy that we start to expand on in lesson 5.